Hi guys, so today we're going to talk about dividing polynomials. Now, polynomial division is a lot like long division that you used to back in 4th and 5th grade. But instead, we're going to follow the same steps, but we're going to use that in regards to polynomials. So we're going to start with doing an example or two of just long division that you learned back in the day, and then we're going to extend that to do the same thing with polynomials. So let's start with this. I go 6 into 4,571. Now, the very first thing we got to look for is how many times 6 goes into 4. But it doesn't. It doesn't go in any time. So what we have to do is move to the next number and look at 45. Now, 6 goes into 45 7 times. Now, after we figure out how many times it goes in, we multiply these numbers, which gives me 42. And then the way I like to think about it is not subtraction, but changing my signs and then adding straight down. So I'm going to change this sign to a negative and then add these straight down. This gives me a 3. So the next step is to bring down that next number. So after the 5 is the 7, we just drag this straight down here. So we have 37 now. So we do the exact same thing we just did. Now we have to check how many times 6 goes into 37 though. So if I figure that out, it goes in 6 times. I multiply these two together once again and get 36. Now I said I needed to change my signs, so I need to change my sign here. And then I need to add straight down. A 37 plus a negative 36 is 1. We repeat that whole thing. Drag down this 1. So now we have an 11. How many times does 6 go in 11? 1 time. So that gives us 6 when I multiply those. I change my sign, and then I add straight down. Then I take this remainder, and I put it over my divisor. So it's going to be 5 over 6. So that would be the answer to this long division problem. I'm going to do one more example before we get into the polynomial long division. So the next one is going to be 7 into, and we'll go with 1, 2, 3, 4, 5, 6, and we'll leave it right there. Follow the exact same steps. How many times does 7 go into 1? It doesn't. How many times does 7 go into 12 then? It goes in 1 time. I multiply these, get a 7, change the sign, and add straight down. Okay, then we bring down the next number and keep repeating that same process the entire time. So I have to multiply what to get to a number that's just below 53. I'm going to multiply 7 by 7. That gives me 49. Say you choose a number that's too big. Say you chose 8. Then this would be 56. And when you subtracted them, you'd get a negative number, which wouldn't be any good. Say you chose a number that was too small. Say you chose 5 here. Sorry, say you chose 6 here. Then you'd get 36 there, which gives you a number that's bigger than 7. So this number should never be bigger than 7, and it should never be negative in this case. So drag down the next number, which is a 4. 7 goes into 44 6 times. Multiply those. I need to change my sign. I need to add straight down. And I need to keep repeating this the entire time. So this is going to be 5 now. 7 goes into 25 3 times. We do multiplication here. 3 times 7 is a 21. Change it to subtraction now, so we're changing the sign, adding straight down. We have a 4, and lastly we have a 6 here. So how many times does 7 go into 46? We know that's going to be 6 times. 6 times 7 is 42. Lastly, change my sign, add straight down. Because there's nothing else I can bring down, 4 is my remainder. I'm going to put that over So these steps are the exact same every single time, whether we're dealing with polynomials or we're dealing with just whole numbers. So on this side over here, I'm going to do long division now with polynomials. So first, we're going to have something like this. X plus 2 that goes into x squared minus 3x plus 11. Okay. So this looks complicated, I understand, but it's the exact same idea. We don't care about this 2 right now, and we don't care about the 3x plus 11 right now. All we care about is these first numbers. So I need to multiply x by something to get to x squared. So if I divide x squared by x, I'm going to get just an x. Okay. So I multiply this by both these. Just like we multiplied the 1 by the 7, we're going to multiply x by x plus 2. So when we do this, we have to distribute that. We have to multiply both these. This is x squared plus 2x now. Because x times x is x squared, and x times a 2 is a 2x. So the next thing we have to do is we have to change our signs. We change this to a negative, change that to a negative now. And then we have to add straight down. When I add these together, these are opposites. They're going to cancel. And I have a negative 3x plus a negative 2x gives me a negative 5x. Okay, so we're at this point here. We have to drag down the next thing. So I have to drag down my plus 11 and do this all over again. What do I need to multiply x by to get to a negative 5x? I don't have an x there. I'm going to have just a negative 5. Now, negative 5 times both of these gives me negative 5x minus 10. Next step I have to do is change my signs, add straight down, and then write my remainder, which is 21, over my divisor. Exact same steps, just using polynomials now to divide. Okay, so we're going to do another example of this. Now, this next example is going to be a little bit longer, and it's going to have something a little different in it. So if I have something like this, x minus 3 divided into x to the 4th minus 3x squared plus 6x minus 11. This problem has something missing in it. If I look at this, I have a linear term, just an x, and I have a constant term, a negative 3. And I look at my dividend right here. I have x to the 4th, I have a negative 3x squared, I have a 6x, and I have a negative 11. Okay, this would be fine if we had everything there, but we don't have everything there. In this one, we have a quartic, quadratic, linear, constant. What we're missing is degree 3, we're missing a cubic. So we need to add that cubic in there by placing a 0 as a placeholder, just so we can do these computations relatively easily. So all I have to do is rewrite this. Rewrite the exact same thing. The only difference now, this should be to the 4th, is we have to add a 0x cubed. Now this could be on either side. So say this was x squared minus 3, I'd want to put a 0x in there too. But it's anything less than that highest exponent. So this is up to the 4th, I would need a 3rd, I need a squared, I need a linear, I need a constant. I need all that stuff in there when I'm doing this. Okay, so I have a negative 3x squared plus 6x and minus an 11. So the only thing changed here is I added a 0x cubed. Now you'll see why I did that in a second. We're going to solve this the exact same way. Same steps as we did here, same as we've been doing for this long division the entire time. Okay, we have to figure out what I need to multiply x by to get to x to the fourth, which is going to give me x cubed times, because x cubed times x is x to the fourth. And then I have x cubed times a negative 3, because I have to distribute this, gives me a negative 3x cubed. Alright, so what I'm supposed to do now is change my signs and add straight down. So this gives me a 3x cubed, and then I have to bring down that next term. So I have a negative 3x squared. Okay, so now we have to repeat the same process over again. What do I multiply x by to get to 3x cubed? I know I'm going to need an x squared, because these have to add to 3, but I need that coefficient too. I need that 3. So a 3x cubed now, and then 3x squared times a negative 3 is negative 9x squared. Next step is always to change your signs and add straight down. Okay. Bring down the next term. Same thing all over again. What do you multiply x by to get to 6x squared? Or if I divide 6x squared by x, I get just a 6x. Distribute here. This is 6x squared minus 18x. Because 6x times x is 6x squared. 6x times a negative 3 is negative 18x. I have to change my signs, and then I have to add straight down. Lastly, I have to bring down this negative 11. And do the same thing one last time. What I need to multiply x by to get to 24x? Just 24. Distribute this. 24x minus 72. I need to change my signs and then add straight down. These cancel and give me 61. 61, I can't bring anything else down. That's going to be my remainder. And I put my remainder over my divisor. That's my answer. These problems can get lengthy sometimes, but as long as you keep everything lined up, you notice my quartics are all lined up, my cubics are all lined up, my quadratics are all lined up, my linears are all lined up, and my constants are all lined up. Everything is going to be nice and easy. It's going to be a lot easier to solve these problems. So if you have any questions, feel free to contact me. You guys have my cell phone number. You have my email. Have a good one.